Okay, real quick, I would recommend you go back and watch the first video first, or excuse me, not the first video, the first set of notes, and then we'll go through I'm going to give you one example. There's two examples here. I'm only going to go through one. A couple things here. You know what the inverse is. I want to talk about a term. We know that this applies when it's one-to-one, which means the inverse applies. And when I say a monotonic on its entire domain, means it's either always increasing or always decreasing. As soon as you go from increasing to decreasing, you no longer would be monotonic, which means you no longer be one-to-one because it would fail the horizontal line test. Right. So this is the key. The inverse's derivative of A is equal to 1 over the derivative of B. And what I mean by that is, here's our steps to solve it. And I recommend that you guys write this every time down this way. Let me clear all this as you go about solving it. So what I mean by that is, if this is the inverse, they're saying plug in 3, get what? In the original function, that's the output for f. So what I mean by that is, this, plugging in the inverse here, is the output for the f. So what we do with that is that allows us to find this point by going in the original function. 3 equals 5x cubed plus 2x minus 5. Solve for 0, so 0 equals 5x cubed plus 2x minus 8. So now we can, now that's 5x cubed. So you'd have to do synthetic division, and it still may not work on some of these. What we can do is we can take this and apply it and run to our calculator. So I'm going to graph this new function I get. So I'm going to go to our graphing calculator, and it's right here for y, 5x cubed plus 2x minus 8. And I'm going to have and graph it. And what you want to do is you want to find that x-intercept, and that's your value. So let's find that 0. So our left boundary is definitely coming in from the left. So we hit enter. Our right boundary is above the x-axis. So my x value, you can't use 1. I want you to not round it. It's 1.05600044. I'm going to write that down. 1.05600044. You want to write that whole thing down. You never want to round to 3 decimal places until your final answer. All right, so now we're going to find the derivative of this function. So all what we had should pop back up. Okay, good. Now the original function, f prime of x equals what? 15x squared plus 2. And then I want to re-emphasize it. So this is what we're finding. This equals 1 over f prime of that 1.05600044. So I don't have room to write that in there, so that's that 1.05, and you know what it is, so blah, 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 right? So then I can go to my calculator again, and I'm going to type this is going to be equal to 1 over this, f prime of that. I'm going to write it down here, 1.05600044. So you're going to type it into this derivative here and then 1 over it. Okay, now let me show you a trick. I'm going to go to the calculator again. Okay, I have this function, the original function, typed in. If I go to my calculator and I hit alpha f2, there's my derivative number 3. That means so if I hit alpha f2 and I hit the derivative, if you have one of the older syntaxes, you can't go about this way. You're going to need to figure it out. So the derivative of our original function, which is in there y equals, if I go to alpha f4, I can choose that first function. Again, I hit alpha f4 to get that. So I'm going to hit the derivative of my function. And for what x value, it was that 1.05600044. And if I hit enter, Now that's f prime of that. Now remember, we're finding the derivative of the inverse for the 3. So it's the reciprocal of this. So 1 divided by that answer we just found. This is our answer. So we would say then 0.053. That's the answer, 0.053. So hopefully that helps us a little bit with how to do it. So let me walk you through the steps of this other example. I'm not going to work it out. You're first going to find this is the output. So you'd set -1 here, subtract it over, then that would become a +2. You'd graph that, find the x-intercept, you plug that into the derivative, and then take the reciprocal.